Where are you sending me? Okay, there we go. All right, who I got in here? Hey, LaQuea. And LaQuea, am I pronouncing that right? Because I know I haven't seen you much in person enough. LaQuea is right. I'm pronouncing that right, right?
Yes, you're pronouncing it
Okay,
right.
good. Because I wasn't. I literally went like an entire year calling a kid incorrectly by their name, and they weren't brave enough to tell me. So I just wanted to make sure I wasn't doing anything wrong. Hey, Kylie. Let me see. Brianna, Lydia, Amani, how are we doing, everybody? Okay. All right.
Good. I'm good.
Good, good, good. Well, let me ask you, because I know this is AP test week, apparently. So give me your stress level, 1 through 10, 10 being maxed. Where are you sitting right now? 10. Oh, my gosh. Okay. I'm so sorry.
I'm about a 9.8.
9.8, 7, 6, somewhere in that range. Okay.
Gotta
Well,
be
LaQuea, let me ask you this. How are you dealing with all that stress then? What are you doing to deal with it?
like what I used to do is I used to like have mental breakdowns and everything, but like I'm trying to take it day by day, trying to do as much as I can, not trying to overdo it. Like when it comes to homework, I do what I can do, and because I used to try to get everything done before it was due because I wanted to not stress about it later, and it just ended up like me stressing about it then. So
Right, yeah.
I just try to do as much as I can. I try to like at least get like at least an hour for myself or something. But yeah, that's what I'm trying to do.
And good. Hey, and to be fair, this is not, for all of you taking all these AP classes, especially, this is not too dissimilar from what actual college is like, because you're going to have things you're going to want to do, and you got to get your classes together, and it's a lot of organizing and taking the victories when you can get them. So I think that's good, especially taking an hour for yourself a day. I've been talking with some other students about that. I think that's really smart. Find whatever it is that keeps you calm and gets you through the day. That's what you need to do. But anyways, like I said, please don't hesitate to email me. Let me know if things are becoming too stressful, because this is a new environment for everybody, including me. I just emailed my professor last night for my doctoral classes, and I said, I'm just going to go ahead and apologize for the paper that I'm turning in, because I already know it's trash. And I think we both realize it's probably going to stay trash, but that's the way it is. I got to get something in for you. I know. If you'd let me make up or work anything on it, I'd be happy to. Because I've been making all those. You guys saw that video this morning, and I've been making those videos and stuff like that for class, and it's taking me way too long to decide what to put in there and how to cut things together. So I haven't been getting my classwork done like I'm supposed to. Does anyone have any questions, speaking of that video from this morning, about that video? Any concerns, questions, comments, things I can address this week?
The workload is starting to pick up.
Workload is starting to pick up. It'll drop back off for a number of you, I think, after this week with AP tests.
In all honesty, I think what's happening is some teachers are trying to overcompensate for being on the computer, but now it's just turned into way too much.
Right.
Because I stayed up till 12 last night doing homework, but I got it done, so I'm happy.
No, I've gotten to the point where if it's 11:25, if it's 11:59 and I haven't turned it in, I'll turn it in tomorrow. I'm not about to stay up because I'm going to get a late grade either way.
Right. And I think that's the good way to look at it, and fair way to do it is you get done what you can get done, and then you give teachers feedback. Like, for example, we had a number of assignments I gave you on Monday, I think. I don't know if you got them all done on Monday, but if you let them build up, they will build up quickly. So let me know. You can send me email, messages, or whatever. But what I will tell you is this first month for us has been kind of rushed because we skipped a week. I think that's for all your AP classes. So I'm hoping that that'll chill out a little bit as we go back into a more of a normal routine. Okay.
And I'm still, Miss Alice, I'm still having submission issues. Again, even though you helped me, because I've submitted a piece of work to a teacher 3 times, and I've had to redo it 3 times because every time I sent it to her, it deleted. So it'd turn up to her blank, and then I'd look back in my computer, and it would be blank on my side as well. So I've had to complete this 5-page document 4 times now.
Okay. Geez, that sounds terrible. All right. Well, if it does happen again, record what you do, and then just shoot me a video of that, and I'll take a look and see if I can figure anything out. Okay. All right. Is there anything else I can address for anybody? Questions, comments, concerns, prayer requests, you name it. What we got?
Mr. Ellis.
Yes, Rihanna.
William said that his Wi-Fi is not working because that he's been moving from house to house. So that he's at his parents' house right now, but her Wi-Fi went completely out, and somebody is gonna come.
Okay, tell him to make sure I'm recording these sessions, so tell him to make sure that I upload this recording. If he doesn't get it in time, that way he can watch it there. Okay.
Okay.
Okay. All right. Let me see here. I gotta get us started. Let me see. Mark late stuff here. All right. So I'm hoping today we can finish up Unit 1. And here's what I'll say about Unit 1 that we're gonna finish up today. Unit 1 is a lot of information, but most of it is supposed to be review from biology or maybe environmental science. I hope that it has been. And it hasn't been too much new information. There will be some, but in the weeks coming, we'll start getting to actual new stuff. So it'll slow down the pace a bit as we learn new stuff. But this should be a review. And if it's not, spend a little extra time. And in fact, I wanted to say this before I forget. I'm willing to stay tomorrow, that's Thursday, after school from 3:30 to 4:30 to answer any questions you have or go over material and stuff like that. Maybe do practice questions or whatever for those who would like to stay. So how many of you would be interested in after school tomorrow, staying and going over some things? Yes? Okay. All right. Well, as long as I have one, I don't mind staying. So if you want to stay for that, feel free. If you don't, just make sure you're doing going over your study guide. I had that video, I think, up there for you, and your practice questions. I cannot stress enough the practice questions. Hopefully we'll have a little bit of time to get to that today. Let me respond here. Okay, so let's start rushing through here. But this is also what I wanted to say. In terms of your test, the percent of Unit 1 that makes up your final test for AP is only 5%. So only 5% of the test will actually be material from this. So if this is a bit of a struggle for you, I don't think you should worry about it as much. Okay, so don't let that bother you. All right, just make sure you know that study guide and you should be good for Friday. Now, let's start talking about today's lesson. So today we're going to start talking about these things called trophic levels. All right, and so if I can, we're talking about trophic levels here. Does anybody know what that prefix or suffix troph means? You've used the word heterotroph, autotroph, like a ton. What does that word troph mean? Not top. Good guess.
Eat.
Yeah, essentially you're talking about food. All right, eating, right? Heterotroph, you eat other things. Autotroph, you eat yourself. That's kind of what that means, but you kind of get the idea. As well, and food. Okay. Oh, on Friday as well. That's great. Okay. All right. Well, yeah. We need to figure something out with that. I can't deal with that right now, but let me talk, and I'll see what I can talk with that teacher about. Anyways, let's continue here with this. So food and nutrition. Let's talk about the stages. All ecosystems depend on a continuous inflow of high-quality energy in order to maintain their structure and function of transferring matter between the environment and organisms via the biogeochemical cycles, which you guys should have already learned about. These biogeochemical cycles are essential for life and demonstrate the conservation of matter. And then lastly, in terrestrial and near-surface marine communities, energy flows from the sun to producers and all the way up to the higher trophic levels. So let's start with this question here. Where does all the energy on Earth come from? I'm very excited.
The sun.
All right, the sun. Wonderful.
That was right.
All right, very good. So the sun, not only does all our energy come from the sun, but on some level, so do all of our atoms. But everything starts with the sun. So who can explain this food chain to me, please?
Can I do it?
Kayla, go ahead. What's you got?
All right. So basically, I can't do it from the sun. That sucks. Anyways.
Yeah. The arrows are the arrows correct?
Right. Shouldn't they be the other way?
What you mean?
The arrows, shouldn't they be the other way?
They're facing.
You mean like this?
Yeah.
Yes.
Well, then what's this?
Nothing.
It's like the wolf eats the deer, but the deer can't eat.
Yes, no, very good, Daly. All right, so this is a little joke I played with Circus, but I'm very impressed because last year no one really got this and it kind of scared me. So that's good. That's promising from biology there. So you should look at this and be like, huh, this doesn't make sense, because it does. It means that the deer eats the wolf, and then the flower eats the deer, and then the flower flies up into space and gets swallowed by the sun. That's what that shows. Each arrow shows very distinctly the flow of energy. And the reason I bring this up is because
Wait,
we actually had, I think, one of the, hello?
Can we go? Are we still using the incorrect one? Or are we gonna move?
Oh, I'll get there. I'll get there. I'm leaving this up here for a reason. All right. So the reason I'm leaving this up is because last year I know one of the FRQs that a student had dealt with food webs. All right. And one of the ways that students have messed this up, and they brought this up with us as teachers, is that they can have this cool, complicated food web, but their arrows are pointing the wrong direction. So what you want to have is this: the energy starting from the sun and making your way through the food chain here. Okay. So these arrows show two things. It shows the flow of energy, okay, from the sun to the plant and then all the way through, but it also shows the flow of matter, okay? Because in order for this deer to grow and get bigger, it's got to get matter from what it eats. So it's got to get matter going to it from this plant. And then the matter, of course, goes to him and then decomposes, etc. So this whole cycling of energy and matter is what's going on with this. Is everybody cool with this idea? Thumbs up?
Yes.
Cool, cool, cool. This is a quote from the standards I read out earlier. I'm curious who can help me finish it. It says, organisms need the blank inflow of high quality energy. Organisms need the what inflow?
Constant.
Yeah, continuous, constant. It can't stop. If that flow of energy stops for any reason, right? What happens?
Death.
Yeah, pretty much it, okay? It has to be constant. It has to be high quality. So let's talk about this in terms of this food web. I know all of you know how food webs work. Now let's see how well you were taught to study it. Okay, repercussions. Whenever we humans make some kind of impact on the environment, there are repercussions for the organisms living there. Everything right now is living in balance. If you've seen The Force Awakens, etc., you know about the balance, right? Between the living and dying and things. So if you mess this balance up, things happen. What if I were to go in and spray algicide all over the ocean and just kill up all those phytoplankton? Help me out with what's going to happen.
Everything else will start dying off. Or what will happen is the little small things that eat the algae will have to try and find an alternate food source, but that will cause problems because whatever was eating that food now has less of it. So everybody will start dying off.
Well, let's be, and this is where I want to stress here, right? When we talk about the FRQs, the reason I have you guys do this discussions is to practice your FRQs. This is an example of an FRQ, a free response question, okay? In a free response question, they're going to ask you to explain the repercussions. So be specific. Don't just talk in generalities. So who specifically is going to suffer when the phytoplankton die?
The krill, what does that say? Cod.
Cod.
And zooplanktons.
Yeah, the zooplankton. All right, so all these things are going, oh, I'm still on that marker there. All right, all these things are going to end up dying out because of this main issue here, right? Because you're messing with the phytoplankton. But then what also happens?
Then the penguins will die because they have no krill.
Everything all the way up, right? And here's what I want to say too, Jessica, is you're right. Zooplankton would start looking for something else to eat. But the problem is, in this scenario, you don't have anything else to eat. These are the only creatures in this environment as far as you know. So you can't just say they find some other food source. You got to say that they're going to die out because they have nothing to eat, okay? Let's try this one. Someone other than Jessica for this one, please. Help me out. What happens if we exterminate all the zooplankton in this food web? Partition resources, good use of word there.
The squid will die. So will the cod.
Will the cod die?
No, because what would happen is if the zooplankton left, that would be there'd be one less thing eating off that resource. So the plankton could actually have more, which means the krill and the cod would have more to eat because there'd be more because there'd be no zooplankton.
Yeah, it's kind of a weird thing to consider, but there's a lot of stuff going on. You kill off the zooplankton, right? The phytoplankton numbers you would expect to start going up, right? Because there's less things eating them. But the problem is the cod are missing a food source, so that means the cod would now start eating more phytoplankton, so they draw the numbers back down. So these things overall may or may not be effective, but we know something's going to happen to them. The squid are definitely gone, and if the squid are gone, then what?
The seals will
be gone.
The seals disappear, and then killer whale numbers go
Down.
Down. It's important you understand numbers going up and numbers going down based off this. All right, I see some good stuff in the chat. I'm sorry I'm not paying attention to it like I should. Penguins. What happens if we kill off the penguins, please?
Mr. Ellis.
Yes.
Wouldn't the zooplankton affect the krill as well? Because the zooplankton arrow points to the krill.
To the krill? Oh, I didn't even see that. Look at you. I thought it was just a box. Yeah, for sure. Krill numbers will start to go down, right? And so that would definitely make phytoplankton numbers, well, I guess
and then the penguins will go down as well.
Penguins will go down as well, yeah. There's a lot of connectedness on this. Very good eye. Let's go back to the penguins here. What happens if we kill out the penguins? Be specific.
The leopard seal would go down.
Would go down. Killer whales would go
down.
Down.
All right. And maybe you'd have more cod around because you have less leopard seals eating them, right? So all these things, they have certain repercussions here. And of course, if the killer whale dies out, last one, what would happen to the ones below it?
They would start increasing.
Start increasing. Going up until they reach something that starts with the letter C.
Carrying capacity.
Carrying capacity. Then they start dying out. The killer whales keep them from reaching that carrying capacity. Very good.
So who keeps the killer whales from reaching their carrying capacity?
So the killer whales would definitely reach carrying capacity based upon the amount of food. Like, so that would just be something they deal with, okay, on their own. But the other organisms wouldn't have to worry about that so much. Okay, we don't have time for this, but normally what I have you do is pick a biome and then go through this thought process of creating a food web. But just to generally talk about it, because you should know what these terms are. Can you help me out, please? What are producers?
They like make like plants.
Yeah, plants. They make glucose. That's why they're producers. They're producing usable energy. Okay, herbivores?
Eat plants.
Eat plants. Carnivores?
Eat meat.
Only meat.
Only meat. What's a consumer?
Somebody that takes stuff, consumes stuff.
Consume. We think economics there, right? But to consume means to eat. Okay, so you've got carnivore consumers, you have omnivore consumers, you have herbivorous consumers, all these things. And speaking of omnivore, what does omnivore mean?
Eat anything.
They eat both meat and plants.
Yeah, if you know your Latin, you know the word omnia. There used to be a place called the Omni in Atlanta. That's where they had all the different events. But omni means all in Latin. So eats everything. And then quaternary consumers. We're not going to talk about that just yet. Yeah, because I want to start with this before I get to quaternary consumers. I don't care about atoms. Biogeochemical cycles. Is everybody good with the biogeochemical cycles here? Yes? Going through the module that you have? Okay.
Yep.
All right, so this is what I want to talk about. We start talking about these things called energy pyramids and talking about trophic levels. Okay? You'll notice here we have producers, primary consumers, secondary consumers, and tertiary consumers. Why do you think these guys right here are called primary consumers?
They eat the producers first.
Yeah, they're the first ones to eat. And what's the other name for a primary consumer then, if they're eating the producers? If they're eating first?
Herbivore?
Yeah, exactly. Each of these has a unique but similar name. So secondary consumers would eat second, and they would be termed?
Omnivore.
Omnivore? Possible.
Yes.
Right? But these are more likely to be carnivores necessarily than omnivores. Okay, so we'll get our carnivores coming in. Primary carnivores, in fact, and then you would have?
Omnivores. Or secondary carnivores.
Secondary carnivores, because again, they're just eating the things below them. You can't say omnivore unless it tells you what they're eating. Everything in this is like a food chain. It's just moving in one direction, okay? So these guys would be herbivores because they eat plants. These guys would be carnivores because they eat the insects. Carnivore because it eats the weasels, mice, rats. Okay. Anyways, there's a really important thing I want to talk about, and I want someone to answer this question if you can. Why are vegetarians right?
What was the question?
Why are vegetarians right?
Because they're getting the most amount of energy thing from the food because they become a direct eater. But when you eat it down the chain, the amount of energy drops.
Yes. So there's a very important term that all of you need to know. And that term is from physics, which most of you guys will not take, but it's a term called entropy. And what that means is every time something is eaten, okay, there's this thing called the 10% rule. You only gain 10% of its energy. The rest of it is lost as heat energy, and you cannot get that back. So as you eat further down the chain, much like she was saying, the numbers and the amounts go down. You start out with 1,000 kilocalories of energy here with the producers and reduce that by 10. You end up with 100 as they get eaten by those. And these ones eat and then goes down to 10. These ones eat, goes down to 1. Every single level you choose to eat at, there's a lot of wasted energy. So if I, for example, am choosing to eat as a vegetarian, I'm eating in this 10,000 kilocalorie area. What if I only eat owls? What if I only eat owls? How much energy am I wasting in that system?
99%.
Yeah, 99% essentially, but you're going from 1,000 down to 1 kilocalories. That's 999 kilocalories of energy that you are essentially wasting, releasing out into the universe and never to come back. That energy is gone because you decided to eat all the way up here. Okay? This is one of the many reasons Mr. Ellis is a terrible person, because he would much rather eat the owl than the grass. But at the end of the day, we might have to make some executive decisions on what we choose to eat. Has anybody realized recently, like for example, Burger King has done some things to promote this? Anybody know what's been happening over at Burger King?
The Impossible Burger.
The Impossible Burger. Anybody tried the Impossible Whopper? Anybody here?
No.
Yes.
not
What?
yet.
The Impossible Whopper at Burger King. Okay.
Nope, and I will never.
Tried it.
You have to eat it. You have to try it because
It's really good.
it's really good. I couldn't even tell. I bought a regular one and I bought an Impossible one and I ate them both. I couldn't tell the difference. I'll go pick one up. Here's what I'll tell you though. I cannot stress this enough. We're gonna get into this more later. Not only is there energy wasted, but we just destroy our environment with how much we eat higher up here on this food chain. Okay, because not only are we losing energy, it takes a lot of carbon dioxide and stuff like that and land space to raise cattle and other things. So we need to start looking at ways to save some energy here, okay? But what I do want to have is, could all of you buzz in and say this word, please, entropy.
Entropy.
All right. Entropy. Has anybody ever played the video game The Witcher 3? Anybody ever played The Witcher 3 before? All right. If you're a Witcher 3 player, you might recognize entropy as kind of the final villain. It's this this cold nothingness. Entropy is based off the second law of thermodynamics. The second law of thermodynamics says that anytime you use energy in any meaningful way, okay, you're going to lose some, if not lots of it, as heat, and you cannot get that back. All the heat on the planet Earth that, you know, radiates from my body goes into outer space and never comes back. It's gone. Energy cannot be created or destroyed. It can only be changed. It gets changed sometimes into heat that can't come back. So the more energy we waste, the more is released as heat. That's 999 kilocalories, okay, of energy releases heat into the universe and gone forever. We can't get that back, okay? And eventually, sometime, spoiler, sorry. Eventually, at some time, the sun is going to go out, and you know we won't have any more of that energy. So
Yeah, how long would we, if the sun poof, how long would we have to live? Like, how long would we survive?
well, I don't know how long we survived. You have 8 minutes and 20 seconds before you'd find out, because that's how long it takes, like, to get to the Earth. But after it happened, I mean, you could run inside and live off generators and coal and stuff, but it would turn to essentially like the surface of the moon. It'd be probably pretty hot in the day, and then, well, no, because the sun's gone, so it'd be just freezing, like below zero. Yeah, it wouldn't last very long. That's for sure.
Yeah.
There's a video about it. They do make videos about it. I imagine we wouldn't last very long if we ran out of sources of energy, because everything's based off plants anyways, coal and oil and stuff like that. All right, here's what I wanted to do. I wanted to share a little video here. I've never shared this before. I just felt like it might be a nice little diversion here from a typical class. This is my favorite band. Their name is Muse, and they had this weird experiment with dubstep on one of their albums. But anyways, if you can see the title up here, it says Muse's The Second Law. They're talking about the second law of thermodynamics, or entropy, that all heat will eventually be lost through entropy. And I'm trying to find closed captioning. I don't know why I can't find it on here, because I wanted to share at least that aspect with you. So no closed captioning. So just listen the best you can. This song is about entropy, the second law of thermodynamics. Here we go.
All natural and technological processes proceed in such a way the availability of the remaining energy decreases in all energy exchanges. If no energy enters or is utilized in the system, the entropy of that system increases. Energy continuously flows from being concentrated to becoming dispersed, spread out, wasted, and useless. New energy can be created and high-grade energy being destroyed. An economy based on endless growth is fundamental laws of thermodynamics will place fixed limits on technological innovation and human advancement. In an isolated system, entropy can only increase as species settle endless growth.
All right, so I promised myself I'd play that because I didn't do it last year. And the reason I wanted to play it is, as weird as it sounds, yeah, vegetarians do rock. Please tell someone I said hi. But the reason I wanted to share that is because this band Muse, they experimented with dubstep, because I think they stopped after that. But what I will say is the topic is important. When they say unsustainable there over and over again, right? What are they talking about being unsustainable?
Energy.
Well, not just energy, but our energy use, all right? So what I would say is when it comes to entropy, right? Anytime we're using energy, like all these lights on in this room right now, all these smart boards, everything running power plants wise, we're just releasing that energy into the universe and we don't get it back. So we have to be more careful about conserving it and eating maybe at lower levels in the food chain, okay? All right, anyways, hopefully that was somewhat entertaining. But now what I need from you is this. Percents work. So you're going to have to find for me the following. Remember that when you talk about food chains, food webs, trophic level pyramids, all these things, you follow what's called the 10% rule. The 10% rule says that every time you eat something, you only gain 10% of its energy. 90% is lost. So what I want to know from you right now is, can you tell me how much energy would be available to a tertiary consumer at the very tippy top? I'll give you a minute. Good luck. Message me privately with your answer. That's a good idea. I never thought about that. That's a good idea. Ooh, tour shirt. Very nice. All right, I'm getting some answers in here. Somewhat consistent. All right. Yeah, that's good. Oh, someone using sig figs over here. Okay. All right. Okay, I'll give you another couple seconds here if you need some more time. But while people are doing that, does anybody know a simple way to take 10% of anything? Any math gurus out there?
You take the 0 out.
You can take the 0 out, or multiply by 0.01, divide by 1,000. All right. What I do is simply enough this. So I start with 192,840 joules. All right. To take 10%, you just move the decimal one place to the left. Divide by 10. Okay. Yeah, very good. So divide by 10. So move the decimal place one place to the left. All right. So that gives us 19,284. Okay. And so again, I take 10%, move the decimal one place to the left. And so now I get 1,928.4. Move the decimal one place to the left, and I get 192.84. That's all it is of 10%. Moving this one place to the left. That's important for tipping. For those of you working in the waiting industry, people need to know more about this. Move the decimal one place to the left, and that gives you 10%. Double it, you get your 20% tip. Okay? All right, so move the decimal, simple enough. So by a show of hands, how many got 192.84? All right, give yourself a high five. That's something because I can't give you one in class, you get the idea. Okay, so moving along here. We have the rest of this here. I don't know. Oh, I wanted to give a different number there. All right, I think that's fine. I'm not really overly concerned about that. Here's what you need to know from what we went over. The fact that trophic has to do with food or nutrients. All right, different trophic levels. The one with photosynthesis, it includes producers. All right, biogeochemical cycles, we already know. Conservation of matter. Matter and energy, this is from physical science, cannot be created or destroyed. It can only be changed. I don't feel like I need to go over that one because that's a pretty consistent one there. Most people understand. Eat everything, eat meat, eat plants, and the 10% rule. Every time something is eaten, you only gain 10% of its energy. Okay? And again, there's your standards one more time. All ecosystems depend on the continuous flow of high quality energy in order to function by transferring matter between environments, because again, it cannot be destroyed. Biogeochemical cycles are essential for life, and terrestrial and near surface marine communities. Energy flows from the sun to the producers, to the lowest trophic levels, to the higher trophic levels. All right, does that seem pretty easy? Nothing about that was overly complicated, right? Okay, so let's talk about something new that might be complicated. We're going to move over to a term. I would say that with environmental science, or do you just tip them based on service? Oh, no, I don't tip them based on service. I don't think that's fair. They don't pay them anything. You'll have to realize that, service member, they don't get paid anything. So I understand the reason, but they might have kids and need that money. So keep that in consideration. All right. So here's what I would say. Let's talk about primary productivity. Most of the environmental science things you're going to talk about are going to be pretty much common sense, as long as you understand what the words mean. So let's look at this word primary productivity. Okay? Primary means first. All right? And we're talking about productivity. So we're talking about producers. Who did we just say were producers not that long ago? Plants, right? So when we talk about primary productivity, we're talking about plants and their ability to produce glucose. All right? So here for primary productivity, it's the rate at which solar energy is converted into glucose via photosynthesis over a unit of time. So now we're going to talk about a little bit of math, but this one's pretty easy. Okay? Just a matter of plugging them into a formula. Okay? So gross. You guys should know what GDP stands for. What is GDP, please?
Gross domestic product.
Gross domestic product. And gross just means what here? What does gross mean in gross domestic product?
The overall combination of it.
Yeah, the overall total. All of it together. You do not do any subtracting for GDP. It's all being added, right? Okay. The reason I bring that up is because GPP, or gross primary productivity, all right, is the total rate of photosynthesis. However, you're then going to have to talk about this idea of net primary productivity. okay? If you remember net force is when you would do things in physical science where like one person goes this way, one person goes this way, and you subtract the forces, right? Sometimes with net force, you're gonna have to take some actual energy away. Because sure, the plants are making glucose, but it takes energy to do that. So when we talk about net primary productivity, we talk about the gross primary productivity here, all right? But we have to subtract the use of energy, which is lost due to respiration. So when we talk about our equation here, it's pretty straightforward. If you want to know what NPP is, the net primary productivity, how much total energy is being added, okay? Then you have to take the gross total all together and subtract respiration. And that gives you the net primary productivity. Because again, respiration is taking energy away. Is that making sense? Does anyone have any questions for me? Okay, sort of. So just know that photosynthesis is going to add energy to any system, okay? And respiration is going to take energy away, all right? And so when you talk about a net, I usually think of like throwing a net on something. You're kind of catching everything. So you're catching the good things and the bad things together. So you're taking the total photosynthesis minus the respiration, okay? And that gives you the net. If you remember that GDP, gross domestic product, is everything all together, gross means like total, that might help, as opposed to net, which is usually where you subtract things, okay?
What's
All right.
GPP again?
Say it one more time.
What is GPP again?
That's gross primary productivity.
All right.
Okay. Now, productivity, that's the photosynthesis unit here, is measured in units of energy per area per unit time. So it's measured in units of energy, kilocalories, per area, meters squared, per unit of time. I don't know why I'm not doing the divide sign there. All right, so year. They can do a number of things here. Instead of kilocalories, they can do joules. Instead of meters, they can do inches squared for area. Instead of years, they can do per second. You're just looking at an area of the earth where you have plants, right, growing. That's my best trees there, all right? You got plants growing. And in that area, how much energy, how much glucose are they producing per year or per second or per minute in this specific area? Remember, that's where you get the meters squared, because that's meters there, and that's meters there, and area is length times width. That gives you meters squared. So you're just talking about a square of area here somewhere. How much energy is being produced, okay? Is everybody okay with what I've just talked about? If you want me to repeat something or go back over it, I don't mind. Are you cool with these ideas? All right. I like to think of environmental science as the following. It's kind of the combination of all your sciences in one, along with all of your math classes in one, because you're going to get an idea of, or have to use all those skills to do well. All right, so in class, we would do this on the desk. Instead, I want you to do this in the chat, and I want you to send this to everybody here so people can see what you're putting in. I want you to recreate two equations for me, please. The chemical equations for photosynthesis and respiration, and I don't want you to look anything up. I just want you to type from memory. And if it's straight trash because you don't remember, it's been too long, that's fine. Okay, we're just trying to access some memories here. So if you wouldn't mind, please give me photosynthesis and respiration. All right. That just says yes. Okay. Maybe she's just agreeing with him. All right. Anybody want some more time, or are we? Oh, we're just taking it in. Okay. Something plus H2O plus sunlight equals glucose. All right. Plant eats sun, digest. Okay. All right. Sunlight plus O2 yields glucose. All right. C6H12, O2 something else. All right. Okay. All right. Just me speaking as a biology student, like I feel some kind of way people that can't do this. So the chemical equations, you have the general idea. So what I tell people, if you want to know these equations, and they might come up, you're going to want to think about what these things need and what they make. So think about a plant, right? In a chemical equation, you have the reactants and you have the products. So we talk about the reactants. What do plants need? Plants need water and they need carbon dioxide, correct? throw in a little sprinkle of sunlight in there, okay? Water, carbon dioxide, and sunlight. You bring them together and they will yield products, which is glucose. If anybody could, what's the chemical formula for glucose, please? I see someone's got it. That's good. Anybody? You could buzz in if that's easier. All right, if you're in biology, you should have this memorized, right? Yeah, from all, that's pretty close. So C6H12O6. That's going to be your glucose there. Very good. All right. Plus, and you release a little bit of oxygen there in the end. Okay? Water plus carbon dioxide and sunlight gives you glucose and oxygen. Should be simple and straightforward there. For respiration, well, what do animals need? Think about what animals need. So let's make my equation here. Animals need glucose. So I can put C6H12O6 plus oxygen. And then when they bring those things together, animals release CO2. They make a little bit of water. And more importantly, they get out energy. Okay? So those things might help you think through it if you're trying to think of what goes in. Think about what plants need and what plants make, what animals need and what animals make through the process. Okay? You almost second guessed. All right. Okay, so knowing these would be helpful, I think, in the future. So just keep that in mind. All right, here's what I want you to do now. Let me get these numbers, so this might be easier. 1, 2, 3, 4, 5, 6, 7, and 8. All right, this says rank in terms of photosynthetic potential. Think about these biomes and which ones are going to have the most potential for photosynthesis. Which ones do you think would have the most primary productivity? Okay, and I want you to rank them from most to least. Okay, type them in with commas between them in the chat. All right, someone sent me their guess. I think that looks pretty good. Maybe I think the beginning though, whoever sent me that private message needs to take a look at it again. All right, pretty good. That looks about right. All right, if someone wants some more time to think, just buzz in and say, give me a second. Anybody want some more time to think?
Give me
a sec.
All right, sure. Interesting. I feel like the first one should be consistent. I feel like everyone should get the same one for the first one. And I find it interesting that we don't. But we'll see. Okay. All right, I think that's enough time. So taking a look at it like this, photosynthetic potential, what should be the first most obvious one?
The tropical rainforest.
Tropical rainforest. I get a lot of other ones there, which kind of surprised me. The rainforest, we know that because it gets the most sunlight, and we know because of the Hadley cells, it gets the most water. What do plants need? So you'd have the most photosynthesis going on in that location. All right, what next do you think?
Real quick, I forgot what an estuary is. What is that?
Estuary is where a river meets the ocean. Oh, I just erased those.
I said swamp and marshlands just because I think that a lot of stuff grows in the swamps.
A lot of stuff grows in the swamps. That's kind of a fair point. Anybody else?
I said deciduous temperate forests.
Yeah, I think you probably, because estuaries are essentially swamps and marshes, I think you knock them down to number 3, bring in the deciduous forest next. Because that's, again, where you get in their Hadley cell, right? And that's where that water starts to fall a lot. That's where you get the deciduous forest, okay? Swamps, estuaries, marshes, definitely you're gonna have a lot of tons of algae there too, right? All right, what do you think comes next then?
What was number 2?
Oh, I think number 2 was swamps.
That's what my answer was.
Okay. Well, I know, just look at what we've got on here. So what do you think comes next in terms of what we have left between these 4?
The boreal forest, maybe?
Maybe the boreal forest or temperate grassland. Which of these two?
You know, I'm kind of second guessing all my choices after I got knocked on the swamp thing.
That's okay. It's just one. You don't really know until you go through it. So what do you think here?
Temperate grasslands.
Temperate grassland, boreal forest, maybe someone similar. But think about this, boreal forest, right? Ooh, versus grassland. That'd be a tough one. I'd say you could probably put them about the same for now. Okay? Here's the thing, guys. You're not going to be asked very specifically on any test, like what's the exact number, because you're not going to know the exact number. And that can depend upon where this is. You have to know the general idea. Which one has the most that's on here? Which one has the least? Which of these two do you think has the least?
No, hold on. Yeah,
I want to go with the tundra.
Tundra desert? Well, the honest answer is maybe it depends on the time of year, right? It depends on the desert. Everything's always kind of general. As long as you got them here at the bottom, right, I think you're in good shape. Whether this one comes first, this one comes second. At the end of the day, it doesn't matter. Because when you take a test, they're going to have a list of biomes, right? And they'll have either desert or tundra on there. I don't know why I can't spell it. And so all you got to do is pick the one that's on there. They won't have both, okay, unless they give you more information. Okay, so don't worry about it so much. Just know in general what's going to have the most photosynthesis, which one's going to have the least. And then the ones in between, they never really ask you questions about those anyways. Is that making sense? Yes? Just use your common sense here on this? Okay. Bring this up here. So taking a look at these process of producers, again, you have energy stored in the seed that's used to release what we call the cotyledons, which come up here through there, and then they access the sunlight and start growing and reproducing from there. So we call them primary producers because they're first, and I want you to take a look at this. So you'll see maps like this probably on any tests or quizzes. And I want you to look at the scale at the bottom. Always look at the scales, always look at the axes. What does it say on the bottom axis there?
I can't read that.
You can't read that? It says gross primary productivity. All right? Which colors have the most gross primary productivity?
The green.
The teal.
Yeah, the teal, the light blue area, right? And then the colors that have the least would be?
Darkest brown on there.
All right, the dark brown. All right, so knowing that, right? The question I have for you is this. Why do we have such amazing GPP, gross primary productivity, in these locations rather than these locations? Why is there so much more in location A than in location B?
Oh, do you want us to?
You could think about it for a second. Anybody, raise your hand if you want to try and answer. Yeah, Lydia, give it a shot.
Is it because it's warmer over there and we also have warmer water, so there's more nutrients in the soil?
All right, well, it's actually, this is like desert area, right? So it's plenty warm over here. It's warm over here, it's warm over here. We're all around the same line of the equator there. So it's not a warmth thing. I got flat land, farmland, soil, precipitation. I think some of you saying precipitation are there, but the question is, why the precipitation here and why no precipitation here? Why precipitation in A and very little precipitation in B? Closer to the coast. I think you're hitting close in on there. More plants in A. The only reason there are more plants in A is because there's more precipitation. So the question is, why more precipitation? Hadley cells is a great guess. It is dry, but the question is why? Why is B dry? Okay? Aren't they different biomes? They are different biomes, but they're different biomes because they have different climates. They have different levels of precipitation. So I go back to this. This is about precipitation. Why the precipitation here? It should be a super obvious reason, because you live here. You know why it rains here all the time. Why does it rain here all the time? Rocky's a good guess there, by the way, for who said that. Why does it rain in Georgia all the time? Thank you, exactly. The Gulf of Mexico right here, okay? It's a bathtub. The sun's constantly pouring energy into it. That water evaporates, and it's got to go somewhere. So where does it go according to the Hadley cell there? It goes north and just dumps rainfall all over us.
Well,
The Pacific rainfall ends up here. And like I think someone said, the Rockies tend to block a lot, and that's true. Mountains do block precipitation. What was that question?
Oh, I was gonna say never mind. You answered it because I was gonna say if the Gulf of Mexico pushes north, shouldn't that section right next to it as well be super green?
It would depend on those Hadley cells and the general direction of the winds. Okay, but those mountains being right there causes deserts to form on the other side. Same thing happens with the Himalayan mountains in Asia as well. Okay, but I just wanted you to be sure and understand what's causing this. It has to do with the rainfall, the climate. If you get rain and you got sunlight, you're gonna get lots of plants. Okay, now let me see. It is currently 11:03. There is what's called the NPP internet activity. And I would like to spend a little bit of time going over it, but I don't have too much time to go over it. So, but before the test, I want to make sure that we understand kind of what it's about. So I'm going to leave this up here. I should say I'm going to leave it up on Canvas for you if you want to do it, but you don't have to be successful. I'd rather just do some of the practice problems here with us together. So what I will say is this, if you want to get more practice with this idea of NPP, net primary productivity, and gross primary productivity, then that worksheet on there, I'll make optional, and you can do that, and I'll try and grade it before Friday for you, okay? But here's all I really need from you. I need you to understand these ideas of gross primary productivity, which is the total amount of stuff produced, the units that it's given in, right? The energy per area per year, all right? And we're gonna start applying that now to problems, to math problems. Because I want to make sure I have a little time to go over the test here at the end. So let's talk here one more time. Gross primary productivity is the total. The net primary is the GPP minus this R. What does this R stand for?
Respiration.
Respiration. Everybody buzzing in or typing in answers when I ask them, you're accessing your Drew. Even if you're mouthing the words with the mute on, you're accessing your Drew. Just make sure you're answering the questions I'm asking. Otherwise, you'll get left behind a little bit here, I think. Okay? So net primary productivity is the GPP, the total, minus the energy used for respiration. Okay? So let's practice it a little bit. And it's not hard at all. Okay? It really isn't. It's just a simple little equation. There might be some work to do with percents here. Okay? But that's about it. Now, let's take a look at this problem. It says net primary productivity, efficiency, and we're not going to learn about efficiency, can be calculated for terrestrial producers when values for insolation energy. Insolation, that word sol has to do with the sun. So when we talk about insolation, we're talking about sunlight. So net primary productivity can be calculated for terrestrial land producers, plants, when values for the sunlight, all right, respiration loss and gross productivity are known. Use the equations below to answer the following problems. So let's look specifically here at number 1, okay? And ignore the rest for right now. So in number 1, it says, in a rice paddy in Southeast Asia, the insolation, that's again, our sun, its technical name is Sol, S-O-L. So when they say insolation, they mean sunlight, okay? The insolation energy is 6 million calories per meter squared per day. The gross productivity of the rice is 0.012 grams, and the respiration loss is 20%. Okay? 1 gram of rice is equivalent to 1,000 calories. All right, so it says calculate the net primary productivity of this rice. So if you can, if you have paper and pencil, just kind of follow along with me and let's do this one together, all right? So if you want to move on ahead, feel free. The net primary productivity, there's an equation for this, equals the gross primary productivity, that's the total amount of energy, minus respiration. Okay? All right. Now, if we're looking up here, it says the gross productivity of the rice, we need that number, right, is 0.012 grams per centimeter squared per day. Okay? Now, here's the tricky part that you're going to have to pay attention to, all right, which is this idea of grams, all right, and rice. There's some conversions that's going to have to go on here, all right? So if I can bring this down a little bit, let in, somebody got knocked out here. Let's do a simple conversion. We want to convert 0.012 grams per centimeter squared per day. And we want to convert that into, or is it calories? So calories per meter squared per day. All right. So what are we doing? We're trying to convert these units here to these units here. Okay? So if you're looking here,
Is that?
where is that? Where do you mean, where is that?
Like, is these like notes or something?
So this is something we worked on, I think it was 2 weeks ago, unit conversions. This is something you should have from chemistry and algebra 1, basic unit conversions. But I'm going over it now, so ask me lots of questions as we go, okay?
I can't really see that.
You can't really see what?
It's like all pixelated.
It's all pixelated? Okay. Well, what I can do is this right here that I'm doing is actually already up online. If you want to go to my study guide and watch that video, I go through how to convert units, okay?
Okay.
But listen along as best you can. And I'm sorry, again, we have to do this virtually at all, okay? But if I can, we have grams per centimeter squared per day. And we want to convert this to calories per meter squared per day. So I'm going to have to do some conversions here to get the units to be the same, all right? In fact, let me make this a little smaller. Okay. So I need to convert 2 things. I need to convert grams into calories, and I convert centimeters squared into meters squared. And it's not overly complicated. I need 2 simple conversions, okay? So I'm going to multiply this by 2 separate fractions. We call them conversion units. So let's start by getting rid of this gram and converting it to calories. If we look over here, we see grams and calories, right? So it says 1 gram of rice is equivalent to 1,000 calories. So if I come down here, I want to get rid of this gram. I'm going to put 1 gram here on the bottom with my conversion unit. Because now this gram on the top, right, and this gram on the bottom can cancel each other out, okay? So I'll put my gram there on the bottom, and I know that is 1,000 calories, because that's what it told me in the problem, okay? So this will enable me to cancel out the G's, but we'll get to that. So that gets us from grams to calories. Now we need to get from centimeters squared to meters squared, okay? So if I can, if we have let me see, centimeters squared needs to be on the bottom, and meters squared needs to be on the top. So we need to have the bigger unit, that's meters, as 1. So if you have 1 meter squared, how many centimeters is that? Or how many centimeters squared would that be? I think going to the restroom might be a bad idea at this moment, but that would be up to you.
Is it 100?
100. All right, so we know we have 1 meter squared, so that's 1 meter, right, of a square times 1 meter of a square. If we convert this, right, to centimeters squared, well, I know 1 meter is 100 centimeters, correct? Yes, 1 meter is 100 centimeters. So then this would become 100 centimeters. So when I multiply 100 times 100, what do I get? I get 4 zeros because there's 2 zeros here and 2 zeros here. And when I multiply them together, I get 4 zeros. So that means there are 10,000 centimeters squared in 1 meter squared. And just to give you an idea, I guess this depends on your math teachers and how much they're teaching you about multiplication and squares and area. But all I did here was, when I saw it said 1 meter squared, I made something that was 1 meter squared. 1 meter times 1 meter is 1 meter squared, right? And then I converted this meter into centimeters, because that's what I want. And I know 1 meter is 100 centimeters. That's why they're called centimeters. Over here, this is also 100 centimeters. So I convert them to a unit that I know, and then I do the area, which is length times width, and I multiply them together. 100 times 100 is 10,000, and centimeters times centimeters is squared. So that's how I would find that specific unit. Okay? Now, I notice that it's very silent, and if you have questions about what I'm doing, I would say buzz in, interrupt me, and make me go back over it. Like I told you, I was an annoying student for a reason. Would anybody like to ask any questions?
Because I was late.
All right, go back is very vague. You need to be more specific about what I need to be doing and where. Because when I get too far,
I'm kind of lost because I wasn't here.
I hear you on that. What I'm saying is, I guess this is being recorded, and you can rewatch this a little bit later. I can't necessarily go all the way back to the beginning now that I've gotten this far, but it is being recorded for you, okay? All right. So once I have all of this, I now can start canceling out my units. My grams will cancel, leaving me with calories. My centimeter squared cancels, leaving me with meters squared. And then I just do the math, and I multiply all the way across here. Would anybody be willing to do that math for me, please? Yeah, that's what I would get here too. So if you're paying attention to the math, you're looking at 0.012 times 1,000 times 1,000. There's 1, 2, 3 zeros. So you move your decimal 1, 2, 3 times, and that gives you 12. Okay, and so that gives you 12 on the top. Unfortunately, on the bottom there is 10,000. So now you're going to divide by 10,000, which means move your decimal 4 times to the left. 1, 2, 3, 4, and that gives you 0.0012. All right. So why am I doing all this? Well, the reason I'm doing all this is because I know they're giving me this unit of calories per meter squared per day. All right. The productivity of the rice is only 0.0012. So there's lots of sunlight, but we're not really making all that much actual energy. So if I can, let me rewrite this as 0.0012 grams per meter squared per day. And that is my GPP. All right, so now I've calculated that. Now what I want to calculate is the NPP, which is simply the GPP here that we have minus the respiration loss. Okay, now if I come up here, all I got to do is now plug this number in that I just calculated. So I'm going to plug in 0.0012 minus respiration. And if I look up here at the top, it tells me respiration loss is 20%. That means 20% of the number I just calculated. Could anybody here tell me what 20% of 0.0012 would be? And for those with calculators, 20% multiply by 0.2. Or take 10% and double it. Yeah, 0.00024. Okay, very, very good. All right, and all I need to do then is do that math. So you can do this in your calculator. You can do this with your rudimentary elementary school subtraction. 0.00024 subtract, carry. That gives us, what was that, 11, let's see, 6, 9, 96. So we get 96, or I should say 0.00096. And that would be calories per meter squared per day, I think it was. And that's my answer. Okay, cool. How many followed along with me on that? Give me a thumbs up if you followed along with all of that and you understood it perfectly. Give me a thumbs down if you didn't understand that and you have no idea what's going on. Okay. If that's the case, just keep this in mind.
What if we're in the middle?
All right, if you're in the middle, that's fine.
Like
Here's what I tell you. You can do the entire AP test with 0 math and pass. If you just refuse to decline to do any math problems, you could do the same thing on my test as well, okay? The reality is math skills tend to be more deficient than they should be, especially in an art school, right? Where some art students sometimes struggle with their math. That's understandable. So what I would say is, if this is too much for you, then you are more than welcome to just set it to the side, okay? Because at the end of the day, last year's test didn't have any math on it, and this year's test, I'm sure, will have math on it. But like I said, it's only one section of one FRQ problem, and you don't have to worry about it if you don't feel like you need to. Is everybody okay with that understanding? Yes? I just wanted to show those of you who understand math kind of what I did and why I did it, converting here from one unit to the other. But at the end of the day, it's really a simple process. It's this basic equation. NPP equals GPP minus respiration loss. What if I gave you the following? What if I said gross primary product was 100 calories? Respiration loss was 10 calories. Could you calculate the net primary productivity for me, please?
90.
Wow, you did that so fast. How did you do that?
I don't know. I'm just gifted.
Just gifted. All right. Any non-gifted students explain how they did that? All right, we're all gifted. Okay. Well, any other gifted students want to share how they did that? Yeah. Plug the numbers in. GPP is 100 calories minus respiration is 10 calories. And that gives me a total of 90 calories. Okay? The numbers being super complex like this don't really matter as long as you remember that. I mean, if there were simpler numbers, I guess it would be easier to look at. But all you do is just subtract them once you calculate what they are. Okay? It's not an overly complicated process, I promise. Any questions about what I just did, or would anybody like me to do another example? All right.
Another example. Please.
Another example? Okay, so let's look at this one here. All right, let me see. We can either, I guess we'll do it the same way we did before. All right, so in Kansas, a wheat field, the installation energy is 5,750,000 calories per meter squared per day. All right, the gross productivity wheat is 0.038, and the respiration loss is about 22%. All right, 1 gram of wheat is equivalent to 850 calories. So what we're going to do here is we're going to try and get these wheat energy units, okay, converted into solar energy units, calories per meter squared per day. Okay, so we're going to convert this to a usable unit. All right, so first thing I'm going to do is I'm going to write out that unit on the left side. If you want to do unit conversions, write out the unit on the left side. All right. And then on the right side, put your equal sign, what you want to convert it to, and put the units you want to change it into. Calories per meter squared per day. Okay? I always put one thing on one side and one thing on the other. Now, your next task is going to be to convert these units. And you do that by canceling out. All right? By adding in what we call equivalent fractions. All right? Fractions that are essentially just one. They balance each other out, so they don't really add anything or take anything away from the equation. All right, so where am I? Oh, erase this. Okay, so I want to convert grams to calories. Do they give me a conversion unit on here somewhere to convert grams to calories? Anybody?
Yes.
Where?
Last sentence.
Last sentence. 1 gram of wheat is equivalent to 850 calories. So I put 1 gram of that wheat is equivalent to 850 calories. That means if I divided these two, the answer would be 1. And any number times 1 is itself. So these conversion units don't affect the value. They just enable me to cancel out and change units. Okay? So what I can do now is I can cancel my grams, and I'm left with calories. The unit that I wanted is now on the top. Okay? What I want to do next is I want to change centimeters squared into meters squared on the top. And we just did this a second ago. Give the big one the number 1, and the smaller one the unit. What did we decide on centimeters squared, by the way?
10,000.
Yeah, 4 zeros. Okay? And then it's just a matter of doing math you've done since elementary school, right? Multiplying fractions, multiply across the top. 0.038 times 850 times 1 gives me I guess I can do it myself. Blah, blah, blah. Or tra-la-la. 32.3. Is that right?
Yeah.
Cool. And we divided by 10,000, which means we're going to move that decimal 4 times to the left. So I'm just going to erase that and move the decimal 1, 2, 3, 4 times. Put a 0 in those openings, and we get 0.00323 calories per meter squared per day. Now, that number, what is that number? Well, that number is the converted gross productivity. So I did all that work to give myself the GPP. And I know that GPP can be useful because it helps me find the NPP. the net primary productivity. So I've got now the gross productivity. That's this number here. So I'm going to plug it in. 0.00323 minus, I'll get MVP, bring that down one. The respiration loss. What is the respiration loss this time?
22%.
22%. So we're going to take our 0.00323 and we're going to find out what 22% of it is. To find a percent of anything, you take that number 22%, you move the decimal 2 times to the left, and that gives you 0.22. And so now, multiply. And what do we get? A really small number, yeah. 0.00, 4 zeros. What was it? 3 zeros or 4 zeros? Did I do something wrong? I think I have 4 zeros on here. 0.0. Oh, I did too many. You're right. It is just 3. Okay. All right. And then it was 71706. All right. So we're working with some small numbers here, but that's not too bad. It's just a matter of plugging it into the calculator. All right. And so plug them in the calculator, and you will get an NPP, which would be, I don't know. I don't feel like calculating that way. Everybody give me that number? Subtract those two. All right, 0.0025194. All right, and that's calories per meter squared per day. All right. So just to recap what you've done here in this problem, right? We divided twice, we multiplied twice, and we subtracted 1 time. Are those overly complicated things to do? No, dividing twice, multiplying twice.
I get it now, pretty much.
Good. But the only thing that is confusing is getting used to real numbers. In math class, you're given easy bake oven problems with easy bake oven numbers sometimes. And that means that when you're given real life stuff with real life numbers, it just looks much. It looks like a lot. But honestly, it's just a matter of keeping your units consistent, multiplying or dividing as you need to. Is everybody okay with that? All right. Am I moving? What time we have lunch? Is it 11:35? How am I doing on time?
Got like 9 minutes left.
Okay. All right. Then in that case, we are almost finished here. All right. And there's another practice problem, but if you want to come by on Thursday, we can do lots of these problems if you would like to. Okay. All right. My next question for you is this: can plants be red?
Maybe.
Maybe, yes or no?
And there's something about it absorbing light.
Absorbing light? What about absorbing light?
Like how they only reflect red, so they can be, so like some plants are like everything but red, and some plants have red in them.
Yeah, they're supposed to be green, and we know from physical science the reason anything is green is because it absorbs all colors except for which color?
Green.
Green, which it reflects, right? That's why things look green. So for a plant to be red, it would have to absorb every other color except for red, all right, reflecting red. Why would a plant do that? Everything else does green. Why would a plant want to be red?
To attract bees and stuff.
That's a cool idea. But those flowers, I think you were addressing, flowers aren't photosynthetic. That's for pollination, but that's a really good guess. I don't think I had time to show the video like I would like, but let me try this. What color is this plant, please?
Green.
Green.
Green? How do you know that?
Because the green line is flat.
All right, so what I want to stress is if you need some time to think about it, please use it. And so those who got that really quickly, well done. It is in fact green. The question is, how do they do that? Well, they do that by doing what you should do anytime you're given a graph. Look at your X and look at your X and look at your Y. All right, and the Y shows light absorbed. Okay, the amount of light absorbed. So we look here, we see violet, blue. All right, all those being absorbed. Okay, green is not being absorbed, and then these colors are. So that means that anything in this range where it's flat is not being absorbed, being reflected. Therefore, you would perceive it to be green. Chlorophyll A, chlorophyll B. They're being reflected. That's why they're low on this absorption scale. So this would normally be a green plant. All right, so the plants we're talking about, they absorb lots of that in the green spectrum. They just don't absorb these ones in the red side. Does anybody know anything unique about red light? What's different about red light to feel different?
It has the least energy.
It has the least energy, exactly. And so where this comes into play, where we have red plants like this, is in the ocean. All right, and the reason I bring this up is because in the ocean, you have colors. Purple has lots of energy, all right? And part of the reason, you can look at how far they get, how deep they get down in the ocean. Part of the reason purple gets stopped pretty early is because it's got so much energy, it just runs into things and kind of gets lost in this upper area because it's going a little bit too much energy. All right, these ones in the middle make it pretty far down, but red, you'll notice, has so little energy, it doesn't get anywhere at all. So where are we likely to find red plants?
At the top.
Maybe at the top? Probably not at the top, though.
Well, technically speaking, the red plants can be at the bottom, but we wouldn't be able to see them because the light wouldn't be able to reflect from there unless you had a special scuba diving.
Yeah, unless you shine a light on them, right? They're not going to really appear like too much. But if you look, red plants are red. I'm sorry, all right, Jessica. So red plants are. I'm sorry. Go ahead one more time.
I'm sorry. Oh, I said red stuff can be down there, but it just won't show.
True, but here's the thing. Why would plants be red? Because anything up here is going to behave like normal because you have all the colors. Anything at the surface is going to be green because, right, you have plenty of red light and they can absorb that and they normally reflect green. But as you move down, there's less red light, okay? So that means that, trying to absorb red is kind of a waste of time. So what they've evolved to do is, at lower levels, since red light doesn't make it very far down, they now reflect red light and absorb green because that's an additional amount of energy they can get. So the deeper you go into the ocean, the more likely you are to encounter red plants or red algae, okay? Does that make that why they use red lights in the dark room? Yes. So that's why in the dark room it's so important to use red lights because if you're doing photography, you don't want blue light messing up your photos with all that energy. So you use red instead. So you can still see it, but it's just not going to cause them any problems. So someone said I cut out, just to go back over this, you're going to find red plants or red algae down here because they reflect red since it doesn't make it far enough down. They don't want red, so they reflect it. Instead, they absorb all these other colors, all right? Green, purple, yellow, blue, they absorb them, and then they end up looking green to us. Or excuse me, they're looking red to us because they're reflecting red and they're absorbing everything else. That was kind of a lot. Does that make sense? Or would anyone like to ask a question about that? All right, cool. All right, and then I think that pretty much takes us through the end. So red algae, for example, rhodophyta. You're going to find this kind of stuff a lot in the bottom there of the ocean, or at least I guess midway down, because it can survive at greater depths because it's absorbing green light as well, okay, as opposed to other types of creatures. There are your vocabulary terms if you want to check them out. And I have just a couple minutes here left to go, but we did cover all of these general topics. Whew. Okay, so last thing I want to say is your test, what you need to know about it. You will be given 25 multiple choice questions for which you will be given 30 minutes to do. All right. One of the things about AP tests is their multiple choice sections are timed and you don't have a whole lot of time. Okay, so you're going to have to go through this very carefully and very quickly. So that's why I'm saying know that study guide forwards and backwards. So when you show up, you're not spending a lot of time thinking about things. Use that study guide, and I went over it as well in a YouTube video I put up there online. And then you will have one FRQ, all right? The FRQ, depending upon the length, will be anywhere from 10 to 20 minutes, which means that you will have either 40 minutes and be done or 50 minutes and be done. So what I would like to do is when we come here in class, if you want to come by on Thursday, I'll go over things that you're confused about, but you got to come with questions, all right? And on Friday, when we show up in class, I'll spend the first part of class going over any other topics you think you want help with before the quiz or before the test, I should say. Does that make sense? That way I can go over it twice here for those who would like me to. FRQ. FRQ stands for free response question. I apologize for using these terms. I know that I do not, what's the word here? I do not have as much time, so I kind of skipped over the intro to the class in terms of what these things are. But a free response question is essentially what your discussion posts are. All right, you're given a topic, something to read, and then they give you a series of questions. 1A, 1B, 1C, 2A, 2B, 2C, and they'll ask you questions about things and ask you for answers. They'll ask you to identify things or explain or describe all the things I'm practicing with you on your discussion posts. So if you want to do well with the FRQ, they're graded out of 10 points, I believe. So if you want to do good with your FRQ, you're going to want to make sure that you, what's the term I'm looking for here? You want to make sure that you check out your discussion posts and read my comments on everything you've done. Okay? Yeah, and so someone asked for the Zoom link tomorrow. All you got to do is join at 3:30 after class, and I will be on there going over whatever you have and whatever you need help with. If you just want to come and listen, you're welcome to, but you're better off coming with actual questions. So hopefully you're studying a little bit in advance and getting ready for it. And any questions if you have, if you want to email me something, I can probably find you some videos to cover some topics if you need help. But as you're studying, don't be afraid to reach out to me and let me know if you want some help explaining something. Okay?
I have a question.
Question, what you got?
Is the study got a grade, or we just like?
No, it's just a study. It's just for you.
Okay.
Yeah. Okay, and I think this one I filled in. The other ones I haven't. The other ones I left blank. That way you can kind of ask questions about. At first, I thought last year it'd be better just to give you the info, but I found people weren't really using it, so I switched it back up to question mode for the rest. Okay, 1134. Like I said, there's a lot here. I get that. This is only 5% of your test, and things will slow down drastically starting next week. Okay? So don't let the math sweat you, because the math at the end of the day, like I said, it's only one part of the test, and you can skip it and still get a 5 easy. Okay? As long as you know the rest of your stuff. So don't worry too much about that. Okay? Any other questions before I let you guys go?
Did y'all do anything like? What did y'all do like before? Like,
I'll share the video up on campus for you. Okay? I'll put it in the recording section.
Is that any like assignments?
There's nothing to do. No, I just went over some material.
Okay.
Okay. All right. Well, and that's all I got. If you want to stay for questions, you're welcome to stay by and ask me questions. Otherwise, you're welcome to go get some lunch, and I will see you guys on Friday. Okay. All right. Adios, folks.
Bye.
Bye.
I'm gonna do the assignment again because I have to. But I'm gonna screen record it and send it to you.
Perfect. Yep.
But I'm gonna screen. Well, I was gonna screen record and take pictures anyway because it.
To show the teacher, right?
Keep bleeding.
Makes sense. I understand. And it might even be worth getting online with your teacher and just sharing your screen and showing him or her.
Oh, I've been trying, but the issue is when I tried and emailed it to her the first time, but then she told me she doesn't do emails. So then I redid it again through Canvas. And then after I redid it again through Canvas the third time, then she was just kind of like, why don't you shoot it to me in the email? And I said, I did, but you told me you don't do emails. So I'm just kind of.
We're trying to make it be Canvas solely. So we want to force that first. And then if we can't make that work, then we'll do that. Because we don't want to do it all the time. Because I'm not going to see your email. Like I normally should. So I don't want to miss it. And that way it's more clear on Canvas, okay? But if you want to message me privately who that teacher is, maybe I can work with them too on it. Yeah?
It's next door. Science. It's a science.
Oh, really? Okay, I got you.
I take 2. You can
all
look
right,
at
I'll talk. We'll talk. Yeah, she's usually pretty tech savvy, so don't worry about it.
No, she's not. Wait. At the end of the hall.
Okay. Well, in that case, yeah, just we'll talk about it. We'll figure it out.
Okay.
Okay.
Thank you.
Yeah.
Bye, Mr. Ellis.
Bye. Hey, what you got? Anybody else? Question?
Yes.
Multiple questions. All right. Go ahead, LaQuay. I think you asked me first.
This is a question about tomorrow. You said you were gonna do like a question thingy.
Question and answer session from 3:30 to 4:30. Yes.
Well, you said that was on Zoom, right?
Yes.
Okay. Well, I actually have to go to the school right after school ends. So if I came to school and went inside your classroom, would that be fine?
I would be okay with that as long as you have a mask on and you sit towards the back of the classroom. It shouldn't be a problem.
Okay, thank you.
But just make sure, I'm cool with it. Just make sure you ask Dr. Ginther or Dr. Williams that they're okay with that. But I don't have a problem with that personally. Okay?
All right.
Okay. Otherwise, just get on your phone or something like that. It's somewhere else in the building, and that should be fine. Okay?
Okay, thank you.
Yeah, you're welcome. All right. Ryan, what you got?
All right. So Oh, sorry. Did you get a text or message from me yesterday?
Yesterday.
Yes, yesterday night, I believe. Or it may have been this morning. I forget when. It was late.
Is that one? I got one about tomorrow being B day. That's a sixth grader. I do
I
not.
used the number on your syllabus.
Okay, that should be correct. Do you have your phone with you? What number you used?
Yeah. The number is 706 748.
Oh no. That's the school. That's a school number. If you go to my Canvas page, my phone number is on the page. As soon as you log in, my phone number's there. I'm sorry about that. It's 706. If you want to type this in right now, I'll give you my number. Okay.
Yeah, if you could do that. But anyway, my question was about the cycle stuff. I wanted to confirm if you had gotten it or not because, and my art teachers can attest this so well. My Canvas has been refusing to submit images on into it. Like
I'm so
whenever I
sorry.
tried to submit any kind of picture or JPEG or anything like that, it just does not submit.
Okay.
It doesn't tell me anything either.
That's crazy.
Yeah, so I want to see if you had gotten that, and if not, what I can do is I can make a Google Drive folder, and I can like put the pictures on the page and share it with you.
That should be fine. Yeah, and I'm sorry that happened. Yeah, just you can share it through Canvas that way too. There should be a Google Drive share thing on there, so I don't mind that either.
I'm gonna be so happy to be back in person.
Yeah, I know. And what I would tell you is go ahead and contact the DIS people, the Department of Information Services, and have them ready to like meet you and like fix your computer on that first day, because that's going to be highly inconvenient for you.
Well, I don't think. Okay, so my theory is that it's not a thing about the computer; it's the thing about my home Wi-Fi. Because my mom, she works at home, and what that means is she has two computers and one big TV that's constantly streaming stuff.
Okay.
And using like a lot of Wi-Fi or internet power.
Okay.
So my theory is that for whatever reason, like, it's just too much, I guess.
It's very possible. I mean, there's all kinds of crazy things that happen with internet for no reason at someone's house, like just your modem's being a little weird, or maybe your Wi-Fi router, whatever you happen to have. So, yeah, come to school, and if it still happens, I think that's a good idea to contact them, because that just makes things, way too inconvenient for you compared to everybody else. So, but that should be an easy fix, I feel like, for them.
Yeah. I don't know. I feel so bad because I've been trying to submit the same
I couldn't
couple
imagine.
of images to Miss
Couldn't
for
imagine.
like the past 3 to 4 weeks.
Couldn't imagine.
And
So, yeah, I feel for. I think I saw you posting on Miss Wilson's page about something like that with your Canvas struggles. So I feel for you.
yeah, and I'm scared because like I don't want Miss Levin to think I'm like the kid who cried Canvas issue.
Kid who cried Canvas, right? Yeah, no, I mean, you worked with Miss Levin for a while, right? So she probably knows you and your work ethic. So
Yeah, I don't know. I'm on my 5th year with her teaching.
Okay, that's good.
Because I got taught by her in 8th grade in Aaron Cohen's.
Oh, lucky you! All right, good deal.
Yeah.
Okay, well, like I said, that's not a problem. And if you're having those issues, just feel free to shoot me a message on Canvas or a text. That works. My number I just typed in the chat there. If you want to write that in and use that, you can send me a text pic of whatever the thing is you're trying to submit as well, and just let me know if it ever gets resolved. Or I guess you don't have to. Just finally submit to Canvas if it gets resolved. But you're welcome to use whatever you need to get it turned in. Okay.
Before you end the call, let me make the new contact with you.
Sure.
Okay, my leg hurts, so let's hurry this up. 987 0077. Ellis. Yes, that's it. There we go. Oh wait. I put your phone number in place of your name. Hold up. Okay, got it.
Got it? All right, good deal, Ryan. All right, well, hey, I appreciate you hanging on and letting me know about those issues. And like I said, if I'm putting it in as late and you have the issues and submit it, it's just me grading, because we just turn into grading machines and we don't always pay attention to the
Right.
content. So if that happens, just shoot me a message and I'll fix
Okay.
it into the campus for you, okay?
Right on.
All right, cool. All right, Ryan, take care. I'll see you Friday, okay?
Have a good day.
All right, you too. Rihanna, you there? All right, see you later.